Hola, ¿cómo estás? How are you? Uh, we are going to have some fun with functions today, which are, kind of, it's the first step you will take for modularity of your code. That was a mouthful, yeah. Modularity. Modules. You're going to be creating modules. Modularity. I love it. I love English. You can do anything with English and it works because it's actually legal for the language it is. Uh, value returning functions, predefined functions, pass by value, pass by reference, and prototypes. Those are the main things that we're going to be talking about and demoing. I have no idea when I'll tell PowerPoint to get lost. So let's just start there, and then we'll start doing some demo as we progress through. Let's see what we got here. We got scope of an identifier. Ooh, that's a good one. Scope. Yeah, let's throw that one in there. That one we definitely don't want to. Scope is a huge one. However, scope is going to be one of the things that you guys have the biggest issue with building the awareness of it because it's so implicit. um, and scope is where your variables are accessible from. And what variables can talk to other variables or be assigned to other variables or be processed with other variables, and where are they located in your program? Are they at file scope or function scope? Did you create the variable in the function? Yes. It cannot be accessed anywhere outside the function. Stuff like that. Some of this we're not going to get into. I don't want this to be a 3 hour because I like to demo as we go so that you can see it. Miniature programs is actually a really good key for kind of thinking about what a function is, because when a function is designed and built, the idea is that this is for code that you never want to have to do again, which means that you want it to make it as generic as possible so that it does one job very well and returns the answer. And that's all you care about. Is you give it the job, the data and the job, and it does it and returns the answer. And that's the idea of a function. And it's also something that creates regions in your code of runtime. And you've been working with a function this whole time. It's called main. Main is your first starting function that's implicitly or automatically started up. Now you're going to be able to define and call your own functions. That's where we're headed into. And for that, you're going to be actually creating your own, what we call kind of a library. And some pre-built functions that you might have seen already are like the square root. These are in the math library. For every programming language out there has a math library that has a power function in it, square root, the floor. Of course, you can build these yourself, but some languages, or most languages, have functions that are kind of traditionally expected to be part of the language. And so you will find, a library, a math library available to you for that. And it's usually just kind of like an import math from math or include math, stuff, So the basics of math calculations, those functions will be in there for you. And of course, that's the CMath header. It used to be called math.h, but that was before we dropped the .h convention. Now we just say CMath in the language. And you know, every language is changing. It's always updating. Um, C++ is no exception. Some of the newer stuff out there I use a lot now. I love it. Some of it's really good improvements. All right, void functions, value returning functions. So here's the thing with void. When void is referred to as, you know, in programming with C++, what it is it's a way of saying nothing. So a void function basically is something that returns nothing. It has a void return value. And you can think of void as, you know, just a big old nothing. uh, and that's why we call it void, because it's the function returns a void value or a nothing burger or whatever, you know. I don't know why I like to use that term nothing burger. I don't even know where that term came from. It's so silly and stupid. But anyways, uh, that's a distinction in programming, that void keyword, and you guys will see it again. It used to be that we had to use that in the argument portion of a function. So you have different parts of a function. You have the arguments, the parameters that you can pass it. That's the data that you want the function to work on. You don't have to pass anything to the function. You can just call a function that's empty that just does something. Or asks for data. Often you don't have data entry in a function though. That's usually done in main somewhere. It does happen. I've done it. And then you have the number of parameters. That's how many arguments. And then you have, hey, what data are we sending? What arguments and parameters? So when I say arguments, parameters, I'm talking about the same thing. They're interchangeable. We just use two different words to refer to the same thing, which is the data that we pass to the function that it's going to work on. And that usually, you know, you're going to start off with working with simple data types and passing those to functions. And then, you know, I mean, you can get into more complex data types that are library specific that you can pass to functions. So any data type that you can declare, initialize, and work with, you can pass to functions. And then, of course, you know, you're going to get an answer back. So, but you don't have to have an answer back. You can just call the function to do what it does, and you don't need to get the answer. You can just call it and move on and know that it's going to get done, something's going to get done, or whatever. And we have an example. I want to kind of just talk about the parts of a function. Often, the heading, just consider the heading as the name, but not only that, but the name, what the function returns, and then what data it takes on. We're going to start with just one argument because you can send multiple arguments. In this case, from the example on the screen, the ABS, absolute value function, takes an integer number. That means we pass a number to it, and it returns an integer, which is the answer of the absolute value of the number that we pass it to it. So the name of the function should in some way reflect what the function does. And then we have the body. The body is the scope area where we actually have the runtime code. So there's two types of code when it comes to functions. There's what I call runtime code and then definition code. The definition code is the heading. It defines what the function's called. It defines what argument it takes. It defines what it returns. The body is the action part. What is actually done. That's the runtime code. That's what actually happens. And that's where the scope is of the function. And that's also surrounded with braces, with brackets. Just, I call them squigglies, curly cues, things, you know. Yeah. So here's an example of a function. Now in the heading, that's this part right here. You see we have the function name. And then we have some kind of list. Now this is just kind of doing straight English. This is not syntactically correct. This isn't actually how we would do it. And then you have the function type as your return type. And then your body is where the actual runtime code goes. And you have a start of the body and you have the end of the body. So here is an example of the absolute value function. And you see here that we declare an integer absolute value with the function name, and then it takes a number. Now this number, you see that we're actually using it in the body. You can declare other variables here, but this number we're using in the body because that's the data that was passed that the function is going to act upon. Then it determines the answer by processing number. And that becomes now the answer, and it returns that answer to the calling point of the wherever it was called from, main. And that's this integer, which is what was returned. Okay, I think I'm telling PowerPoint to get lost. Let's go through everything, the big kahungas that we need to talk about today in demo. Let's go through this again real quick, and then we're going to say PowerPoint be gone. Let's see, pass by value, pass by reference. We're going to talk about scope, value returning, value. We're going to demo value returning, and arguments, definitely parameters. Now, this one, function prototypes are kind of, that one we'll do towards the end. Because I really kind of don't like function prototypes. I don't think that they should be used until you end up, you know, when you want to make your code all nice and pretty, you go ahead and put in function prototypes. So let's see, everything else I think I'm going to leave. Pass by value, by reference, value returning, arguments, and prototypes, and scope. Those are the big kahungas. Okay, let's start with just working with a function. And you know, I said we're going to start with prototypes first or last. No, we're still going to do it that way. We're going to do it that way. That's fine. That'll work out. It'll work out. Yes, it will. Don't worry. Be happy. That's a silly song. That's a silly song. Alrighty. Oh, what's this? This is my website. No, we want this. Here we go. All right. Let's wait for Visual Studio to load. I promise this machine is actually halfway decent. It's Visual Studio that's the problem. Because it's so bloated with crap. It really is. But you can do so much cool stuff on it. And magically, we have arrived. We are here now. We are doing functions. All right. Oops. You have been working with a function this whole time. It's called main. It is started by another process. The process starts it, and you return a number. If you return a 0, then that you're telling the process that started it that the function or your program ran successfully. That's actually how the whole Unix Linux operating system works, is value returning function C code. Yeah, it's ridiculous. So in this case, main runs returns the answer to the process that started this process. And it could be something as simple as you double clicking on the exe and the operating system starting it up for you, or putting it into command line to start up the main or the program itself. So you see we've got some includes here that we probably don't need, so we're going to get rid of those. And that's kind of our bare bones. Now let's begin with a function. Now, and I want to talk about a little bit about where the proper functions, where functions belong. And because I'm a fan of the top-down programming, because it's just the way things are. However, if you use prototypes, you can make your code easier to follow and read, and or give somebody that's looking at your code kind of a brief snapshot of what's there. That's the main reason for prototypes. So I'm going to show you prototypes later, but I want you to understand that prototypes are not for development code. It's for production release code. It's when you give your code to somebody else that wants to read it and look at the code. That's what prototypes are for. So you do not use prototypes when you start programming. It's at the end when the program is done that you implement prototypes. And I'm going to model that properly today with our example. And let's go with a simple example. Let's go through this list. We want scope, passed by value by reference, value returning, and arguments and function prototypes. So let's define our first function. The name of our function. Now we want three things that we need: return type, void, nothing, int, double, string, any kind of primitive data type or object. And then the third thing we want is the name of the function, and then arguments, which if they were nothing, we just leave it empty like that. So right here, main is not taking any arguments, which it can, by the way. argc and argv. You might want to look into argc and argv, guys. Look into that, because that stuff is the G way of programming. Okay, that's where you really know what you're doing. Let's use some argc and argv. All right, now arguments, and then body, what it does. So let's start with the name, and we're gonna do an example function called print name. Okay, now I'm going to define this function so that it returns nothing and it takes on no arguments. Actually, if it's printing a name, I actually should be sending the name, shouldn't I? So we're going to do argument based one. And just for giggles, let's do it this way first. Because we're going to be literal. We're going to be funny literal, okay? Yeah, we're going to be funny literal. What does that mean? Yeah, this is what it means. Funny literal. Yeah. Okay, so what this does is this is just an output function. I have the body, the scope, is the start of the function, the end of the function, what it does. That's the body. And then it doesn't return anything to what calls the function. So this is definition code. We say print name. It takes no arguments. So we have not done any runtime code. Or what? Excuse me. This is runtime code. We have not called the function for runtime. We've defined the function so it can be called. And that's why it has to be above main. We cannot put the definition of a function down here. Well, we can, but you have to use prototypes. But that's the wrong way of doing things. You start out this way first. Then when you go to production, that's when you do prototypes. So you can't do that. Because main, there's no way that main knows what print name is. Because it hasn't been defined yet. And that's why it's definition code. It's also runtime code because it outputs name, but it has to be defined top down, just like we've talked about with how programming languages work. Every programming language works this way. Hold on. Modern, up-to-date programming languages work this way. What they do is they do two passes. They will compile or look at the code twice, and they will detect when you have defined a function after you're actually using it. And they will say, oh, okay, we know that that's defined afterwards, so it's all right. And that's the way the higher level, I like to call them tertiary or super languages, Python, C#, JavaScript, super managed and very slow and bloated. It's not where if you're gonna, do real jobs and make the big bucks, it's in the fastest stuff out there. That's where it's at. Always been that way. Now, if it needs to be something that's highly abstract, then those super languages are great. So this is incorrect. In fact, we probably should be able to get a build area. I don't think the latest update that they do two passes. You still have to have either it above, defined above, or use a prototype. So it says here, there's an error, and it's because I'm using the wrong version. Again, I built this with a higher level Visual Studio Code. So I got to open it with the newer level. Yeah, it opened up in an older version. Okay, now let's look at this error. At least I don't think I started lying to you yet. One failed. Error. Print name. Identifier not found. And you see a little arrow here. It's saying, what are you doing? I don't know what that is. Don't be stupid. And so what that means is that you got to put the definition above. Just like we've talked about before, top-down programming. Every language works that way. Other languages do things to get around that. But those things, those extra steps, make those languages more bloated and not as fast. All right, now this will compile. So yes, yay! I know what print name is. You've got it defined up here. I know what you are talking about. That's great. All right. So let's set. I'm just gonna throw some junk in here. Ooh, that is real junk. Dang, I was being literal with that. Okay. Just so we have a compile or a breakpoint. That's all. I just want to have a breakpoint where we can do a step over. So there's no purpose for I. Okay, so now let's just look at what happens. Because what a function is, inviolably, okay, I'm done with using big words. It's done. Okay, no, I'm not done. I just use them too much, and I tend to make them up as I go along. Some of the stupid words I make up. It's runtime. That's what a function's for. Is to change your runtime to the function for processing. And so when you call a function, your runtime goes to it. Okay, here's our runtime right now. We're starting out with main, step over. Okay, now this is where, I want to examine what's going on in the print name function. We have not run this line of code yet. And for this, if I just did a step over, it would run the function and go right down to return 0. But if I want to examine what's going on, I can use now what's called step into. So I'm going to use the step into so that the runtime shows appropriately it going into the function. So you can visualize what's going on. Okay, and then it outputs name. And then the runtime comes back and it continues on. It continues on to do whatever you got down here. So when the runtime comes back, your runtime goes up here, boop, 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 done. And then it comes back to the calling point, guys. Comes back to here and then continues on and does this. Okay, let's look at that one more time. Here's our runtime. Boom. It's going top down like it should. Step into. Keeping on going. Our runtime then comes back and goes down to the next line after it's done with line 16. Now it's going to go down to here. Step over. And then the function's done and the program's done. And that's what a function is for. That's all it does. Is it allows you to add modularity. Oh, I love me some words. No, okay, I did lie to you. I'm keeping it up. All right. But that's the idea of it, is let's break up our runtime, what our code does, into manageable pieces that we put off to the side, and then we put all these little jobs together to complete one full job. And so these are tools. Functions are tools that you create. You also can add libraries and use tools that have already been created for you, like CMath. Now let's look at a little bit more on this void. It used to be that you would put void here as well. And I used to joke that in programming, nothing is something. Because when we used to put void there, that would signify that this takes no arguments, and you would call it like this. But now you can just put nothing there. Now, what if we wanted this thing, instead of to just do output name, we wanted to have it so that we send it the name to output. And the data type that we're going to send it, and you can call it name, or whatever. It's going to be a copy of what is sent from here. Okay, now we have declared a fname variable called Josh, called fname with the, we're calling print name here, and you see it already has an error too few arguments in function call. It's already showing some red squigglies down here. And that's because I've defined this function that it requires a name. And you can do a literal here. Just literally type in a string. Or you would use a variable. And the whole goal of this is to output name. Now, let's talk about how a function works with arguments. This fname is only in the scope of main. It does not exist over here. And in fact, when you pass it, fname, you're not actually passing the string you created here. Because what it does is it makes a copy of it. It makes a copy of fname and it comes in as name. So that means if you change it here, it's not going to reflect over here. And I'm going to show you that. In fact, let's do that as part of the example. Let's pretend that our hacker got into our name. I don't know, whatever. I'm being silly. Hackers love to go into websites and deface them and put weird stuff on them just to, I guess it gives them street cred. I don't even know if they call it street cred, whatever they call it. All right, string name. And let's just pretend this isn't here and we just passed in name and we want to output it. Because I want to show you why pass by value and how it works. So right here, let's set a breakpoint right there. Let's comment this out for now and we will redo it with it in. And let's do this. Okay, now let's run it. Okay, fname has been assigned Josh. I'm going to step into this. And we go into another scope. You see it's no longer down here. Only name is here for your locals. Because what the function call does is it makes a copy of name and it's not the same variable as fname. And then we do the job and we come back and we move along. And you'll see our output right there. Then we output name again. Okay. Now here's what I mean by pass by value. Because when we pass in fname, we're not actually passing fname. We're passing that copy. And in fact, we need to get on the whiteboard for this. You guys got to have some structured knowledge of variables and how they actually look on memory. And I'm going to get some scribbles out. Yeah, sorry, it's happening. Okay, think about variables as kind of a box. It's a box. If I can draw a decent one. And let's call this fname is the first one that we create. And when we create it, we assign Josh to it. And in RAM, fname, let's say that it's located at address 3000. Now this is implicit. This is done behind the scenes, and it goes on to your stack, your automated memory given, the RAM given to your process when it starts up. And you just declare the variable for it. We've talked about it before. Okay, moving on. So at address 3000 till the end, you know, let's say that it goes, fname goes from address 3000 to 3010. You know, it's a 10 byte string, or, you know, that's a big string, but okay. So at address 3000, that's where Josh lives and breathes. Fname only is available in main. It was declared in main. And so it's in the scope of main. And when you call it, or when you use it, it lives at address 3000. Now, when we pass fname to the function, when fname goes into the function, what ends up happening is a whole new variable is made. A whole new variable is made called name. And it has its own address. Let's say it's at 4000. And then what they do is they take the value inside of for fname and they copy it and put it inside of this new variable. At the scope, this name only exists in the scope of that function print name. It only exists in print main. Print name. Print main and print name. Okay, so when you call that function, a copy of or a whole nother variable is created. Then they take the value in the argument that was passed and copy it over to the new variable. And then we use this new variable in the scope of print name. And that's why it's copy by value. That's when we say pass by value, not copy by value. Pass by value for a function is a copy is made. So what does that mean? What that means is if I change this variable, even if I call it the same name, this variable is not this one. It's the same name. You're saying, no, Mr. B, it's the same name. No, it's not in the same scope. Fname here only exists in print name. Fname here only exists in main. Now, if you put a variable at function scope all the way up above, now we got problems. Because fname is now at file scope and it's accessible here and here. If you put it down here, now it's no longer a problem. It's at file scope, but it's below. So, whatever. Okay, so that pass by value is kind of an important understanding, because if we change it in this function, it's not going to get changed over here. So we say print name, fname, we output fname, it's still going to be Josh. It's not going to be this guy right here. Okay, let's look at that. Step over. Here's fname. It's got Josh in it. Step into. Now we're changing what we passed. It's no longer going to have Josh in it. But remember, we're changing a copy. We're not changing the actual variable that lives and breathes inside of main called fname. Okay, now we've got a defaced website there. Okay, now, but we go back to this scope, and in this scope, look, fname is Josh again. And that's because they're not the same variables. They're totally different. One is a copy of the value of the initial one. And so if you change it in the function, it does not get changed from the scope of where it was passed into the function. Its calling point. Okay, now you may need to really consider that because it's very important understanding of functions. And we're going to get to pass by reference. I'm going to have to circle that and say, yeah, we better not forget pass by reference, but we need to get to other things right now. We will do pass by reference at the very end. All right, now let's make this function a little bit different, and let's call it add, and we're going to have 2 arguments now. And then we're going to have a value returning, which is going to be we're going to have it add 2 variables and return the answer of the sum. So that needs to be integer. We want it to return the sum. And if we put integer here, then that means we need to return an integer. So if we're passing first and second, we need to have an integer called sum and assign it equal to first plus second. And then we return sum. Okay, now you notice the comma here? You can have as many arguments as you want. Here's a general rule. If you go beyond 7 arguments in a function, unless it's very purposeful and it really needs to happen, you're doing something wrong. You haven't designed it right. I normally do not go beyond 4 arguments in a function. If you're sending 7 arguments to a function, then you probably should break that down into multiple functions. All right, let's look at behavior now and how this actually happens. But when I call this function, I've declared or defined that an integer is going to be returned as an answer, which means I need to accept that answer from the calling point of our function. And so I'm going to assign I equal to add, and we're going to do literals here, 5 and 6. I'm going to send it a literal 5 and 6. You can create variable names and assign those as well. You know, you could put I in here, you know. I'm just using literals to be lazy. Okay, I gets the answer. And let's throw a little token output here just for fun, just so that we have something to reference the runtime as we debug. Okay, I'm going to set a breakpoint, and let's look at what happens. I is accepting the answer of this function add that returns the sum. C++, you can only return 1 item. I don't think they've updated it where you can, they might have updated it where you can return 2. Python, you can return 2, but the general rule, you're only able to return 1. I think C++ 11, the latest update, might do multiple returns because I think I did it in some of my code that I've built. Yeah, you know, I've been doing AI agent assistance for writing code, and it's kind of the new way of doing things. It's where you have an AI directly embedded in your development environment. That's the way things are going. Okay, I'm getting off track. Let's get back on track. All right, let's see here. We got, we're going to demo this. All right, here we go. Okay, I'm going to add, I'm sending 5 and 6. I'm going to step into, and you see the first number gets, why is it saying 1? Oh, it's just giving us crap because it hasn't run the line of code yet. Okay, now we should see first is 5, the 5 we passed. The second is 6, right there. Okay, we're going to add first and second. into sum. So now sum equals 11. That sum is returned, and I is going to catch that value. Okay. The function has been called. Now I is 11. That is an example of two arguments and working with a return. Okay, we've got pass by value done. I've demoed value returning and multiple arguments. They are separated with commas. This can get a little wacky when you add in default arguments, guys. I'm not going to get deep into that. I want to get into a demo here, and that's going to be something that you guys can read about and work on some tutorials about for default arguments. I suggest looking into it, definitely, because I use them. They're used a lot. Okay, and now we've got pass by reference. Okay, let's say this. What if we wanted the function to process a variable and change the variable and the variable that we pass? If we wanted a process that changed the variable that we pass, it would look like this. This is an example, but now what we do is what's called a pass by reference. And now when I call I'm going to then assign it, and you can't really use the literal when you're, yeah, you might be able to. That's all right. Okay, you notice how I'm doing 3 arguments now. I'm passing 2 literals, which are the numbers that are going to be added, and I'm passing this variable called s. Because a pass by reference works differently than a pass by value. And so what we're going to do is you can do it with pointers. We're not talking about pointers, but you put a little ampersand in front of it. And what you're telling it to do is not make a copy. You're saying, don't make a copy. I want you to use the variable I created here in the scope of this function. So let's talk about that. Okay, s is what we're passing in. Okay, dun 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 dun. Whiteboard time. Oh, I know you, Mr. B's left-hand scribbles. Here we come. Pass by reference. All right, so let's get into this pass by reference. The variable s. The variable s is the variable that we create that we want the answer from, or that we want to get the answer. Because a pass by reference allows you to change a variable in some other scope, like main and s. So when s is created, that's an s. No, that's not an x. That's something else. Okay, this is a better s. There we go. Okay, so s is a variable that has an address, implicit address, and in it I think we just have 0 or nothing. When you do a pass by reference, what ends up happening is a copy is not made. What ends up happening is a pointer is made. And a pointer called sum is made that, yeah, has its own address. And this is all happening behind the scenes. But what it does is it stores the address of S. So that when you change sum, since sum goes to 5,000, address 5,000, which is S, you're able to, since sum is pointing over here to this guy, when you change it, you're actually changing S. So what you're doing when, without all this crap, is you're actually passing the variable, the whole thing, because you're just passing what matters, where it's located. And then sum is then given that value, and then you change sum, and since sum is also pointing to address 5,000, or is, 5,000, you actually end up changing S from another scope. And that's the way that you can do things without going to global variables. Global variables are a big no-no. We don't put variables up here called sum and start using them down here. If we have to have a global variable, most variables that are created at file scope are for sharing amongst multiple files. Most variables that are created inside of a function, they're not something that's going to be shared with files. They can be shared with other functions by pass by reference. And so let's look at what ends up happening with this pass by reference now. I think I'm doing the... Oh God, I'm stupid. All right, here we go. S is defined. We pass to the add function what we want it to add, and then we pass by reference what we want it to equal. And when you're working with functions out there and awareness of how the function works, this is very important because some functions don't return the answer. Some functions you pass a variable into the function and that's where they put the answer. So we're passing by reference, and when we get in there, you'll see that sum is going to be equal to 0 here shortly. There we go. See, sum is 0. Okay, so we didn't make a copy of it. We're actually passing S. So now we're going to set sum equal to first plus second. Oh, we got to back up. That's the whole point. We want to output the answer, don't we? Yep. Okay. Let's get caught up. Boom, boom, boom. There we go. All right, sum is 0 like we assigned it in main. Now we're going to change it, and because we did a pass by reference, we're also changing S, which is the same as sum in this case. Okay, now you see down here, S, you see it's now 11. That's pass by reference. And that's what it's used for, is to get an answer. And also it's a way around the problem of multiple variables. Let's say that you wanted to return 5 answers. You can't return 5 answers. That you would do with an array and you know, pass by reference. It's a way to get beyond the issues of the returns, the limitations of return. Okay, so we got pass by reference. Good. Where are we at on our list? We did discuss scope. Not really. Okay, sum is over here. It's not in here. That's illegal. S, the name S is in here, but it's referenced with sum. That's illegal. Now, the big baddie. You can just put sum up here so that it's at global scope, so that every function in the file has access to it. Which then you wouldn't need this or this. Well, no, you would still have this. You would, you know, you would be working with sum. So you wouldn't need, well, what am I doing here? You wouldn't need to pass it anymore. You would just take that out. And then you could output sum down here because it's global. When you're first starting out and learning programming, the temptation to do this is pretty hard, but we don't do it. We either use pass by value or pass by reference, unless it's a variable intended to be shared amongst or in another file. It should not be global. Don't use them unless you're sharing variables to another file. Unless you want, and what that is project scope. So let's get into scope real quick. We need to do the hierarchy. We actually need to do that. Yeah. Okay. Okay, so that's what I call project scope. So global variables are both file scope and can be at project scope, shared amongst multiple files, programming files, CPP files, program files. Yeah. So here is how scope works. It's a hierarchy. Wait, did I shut down my stupid whiteboard? Yeah, I did. Yeah, you're gonna see a journal of scribbles. Look at all those nightmares. Look at, oh my goodness. I can't look at them. I can't. All right, here is the hierarchy. The very bottom scope is function. More scribbles, guys. More, that's function scope. Okay, so that means that the variable is only accessible inside a particular function. Then you can have file scope, which means that the variable can be shared amongst multiple functions or multiple files, because then that would be a variable at project scope. Because a variable at file scope is also could be a variable at project scope, and they use the extern keyword is used so that variables can be shared across multiple files. I call that your project scope. Okay, now what if you have two projects? One project creates a library that the other project uses. Yep, you can have variables that are shared amongst your workspace scope. This is your SLN file in Visual Studio Code. This is your VC, whatever, VC what is it? It's VC something. VCX proj. It VCX proj. Oh God, I've ruined something. Oh my goodness. Why do you do this to me? Okay. All right. Oh my goodness. Okay. VCX proj. So that's what your project file is. And you can share variables amongst multiple projects. That's workspace scope. That's your SLN file. This is your VCX proj file. Now, other integrated development environments has similar scopes, where you have a project, but also a workspace that can contain multiple projects. Right now, you just have one workspace, one project. And some IDEs won't give you the project scope or the workspace scope. You just work within the project scope. And so those are where variables are defined, instantiated, and used. So that's where they can be used. That's scope. Variables created at function scope can only be used in the function. Variables created at file scope can only be used in the functions of that file. Variables created at project scope can only be used amongst files in that project. Variables at workspace scope are available to be used amongst multiple projects. All right, scope is done. Scribbles are over. All right, last thing, function prototypes. Now again, you don't develop with these. This is what you do at the end when you're done developing, because I guarantee you're going to have a nightmare going back between your function definition and your function prototype. It gets to be just stupid ridiculous. So I only ever do prototypes when I am ready to release the code. It's production level. That means multiple eyes are going to be looking at it. And the reason why we use prototypes is so that those multiple eyes can look at the code without getting stuck in the mess of all the functions. They can look at the code, the top of the code, see all the prototypes, and get an idea of what that code does. And that allows us to put our function definitions down below main. So this causes problems, because now we can no longer call add because it's defined down here. What we can do is we can say, okay, Mr. Compiler, this function does exist. I promise it exists. It exists. It does. And this is what it takes. It takes an integer, and a integer reference or pointer. You do not need the names. So you just get rid of it. And you see how nice and easy that is? Prototype done. Over. Yeah. Done and over. It's done. That's how you do prototypes. That's the way it should be done. And then when you put out this code as production ready, somebody just has to look at all the functions that you have up here, all the function prototypes. And they will get an idea of what your code does. And that's pretty much the reason for it. So don't start out writing code with prototypes. You do it at the end, guys, because it becomes a real hassle of a nightmare going back and forth while you're developing on what your function is going to be using, returning, etc., because you have to change it in 2 spots. Make it so you only change it in 1 spot first, then take all your functions, put them above, make them into prototypes, just like I showed you. And that's the best way of doing prototypes and thinking about the reason for prototypes is not just, it's not just for, well, I mean, what's the reason for prototypes, really? To make things look easier and be more digestible. Because you're releasing the code for multiple eyes to see. It's called common courtesy, I guess. You know, something like that. Whatever. All right, guys. We're going to go talk to Sandra. I think I hit the big ones. Boop, boop, boop. Yep, I hit everything. All right, guys. Take care. Bye.